Good afternoon, everyone. My name is Lander Stone, and today I'll be sharing my presentation, Evaluating Vegetation's Relationship to Income. I'm here with the Auburn University Department of Geosciences, and I'd like to give acknowledgments to Ms. Mallory Jordan and Dr. Steph Rogers for their assistance in helping with the processing techniques, especially the pre-processing for this project. So, just to get going, my objective for this project was to determine whether income levels are correlated to vegetation levels as shown by regression analysis. And this is pretty much similar to my title, Evaluating Vegetation's Relationship to Income. But this brings about a strange question. So, what the heck do vegetation and income have to do with each other? Well, I became interested in this project after reading a paper by Becker et al. 2019, who found that reduced exposure to vegetation and/or vegetation degradation has been shown to negatively affect human health. And this was done via a proxy with Medicaid spending. So what I was interested in is to see, well, if we know that certain areas are having increased Medicaid spending as a result of reduced vegetation, are certain areas more affected more affected by this increased spending? Or in my case, I wanted to see, is there a relationship here between income and vegetation? And that could influence this other paper's results as well as lead to other studies in this field. So for myself, I hypothesized that in areas with lower income, there would also be lower vegetation, and in areas with higher income, there would also be higher vegetation. And how I went about doing this, or my methodology for discovering whether or not this was true, was to utilize the 2023 National Land Cover Dataset, or NLCD, and then compare it to 2023 US Census data on income via a regression analysis. So the NLCD is a very commonly used data set. It was used in the Becker et al. 2019 paper that inspired me to do this work. And I used the updated version for this project, which spans from 1985 to 2023. But since I was looking at income for 2023, I selected the 2023 NLCD data. So, and as well, I also used the US Census determination for counties, and specifically in the state of Alabama, as a subgroup to study this relationship. To be able to do this regression analysis, though, there were several pre-processing steps that were required to be able to do this. And to start out, I worked at creating this map here. All my processing from start to finish was done in ArcGIS Pro. And this NLCD vegetation map, so wetland, forest, and then no ag or urban, covered specifically 7 data types. And I also included major Alabama cities, but we'll get back to that in a second. So to get this, I projected Alabama to the same as the NLCD so that the area would be calculated properly, extracted by mask to get the Alabama region for the NLCD data since it covers the whole United States, built a raster attribute table. So with the new update of NLCD, a raster attribute table does not come with the data set, so it is required to build one. And then from there, I was able to do something called a reclassify to develop a vegetation level. So NLCD comes from satellite imagery. It has 30 by 30 meter cells that are equivalent to a different type of, well, this is area, so 30 by 30 meter area, and it's turned into one kind of like data type. And so there are 17 total data types within the NLCD. And for the purposes of my study, I included as vegetation, I included deciduous forest, evergreen forest, mixed forest, shrub/scrub, grassland, wetlands, and woody wetlands, excuse me, and emergent herbaceous wetlands. And I excluded water, snow, the 4 kinds of developed infrastructure, so from least developed to most developed, but all 4 were considered developed. I also excluded barren land, pasture, and cultivated crops. So this means excluding agriculture, barren areas, water and snow, and developed regions, and focusing exclusively on what I consider to be vegetation types or natural vegetation, or generally natural vegetation, not cultivated. So once I had my raster attribute table, these were able to be differentiated from each other, and I could reclassify my desired 7 data, the forests, the wetlands, and the grass and shrubs, into one vegetation type and extract by attributes to get just vegetation, which gave me this map right here. So each of these cells, each of these little green areas is a single cell, and that's just vegetation, one of those types. And what we find is that in a lot of ways, this map makes a lot of sense. Here we have the Birmingham area, over here, Auburn and Opelika. Down here we see Mobile. And in each of these areas that have a lot of development, we see a lack of vegetation, just as one might expect. But because I'm trying to compare this at the county level, I aggregated vegetation to Alabama counties. And we find that certain counties have higher vegetation or are the most vegetated to the least vegetated. And up here in the north, we see the least vegetated counties. And down here in the southwest, we see very highly vegetated counties, even counties that have high amounts of development as seen from this map. So this leads into my consideration at the end. But now that I have my Alabama counties map, I'm able to run my regression analysis. As is typical practice, I did an ordinary least squares regression first. And so ordinary least squares does a global regression analysis covering the whole study area and assuming that there isn't differentiation in between counties. So it assumes the relationship is the same across the state. Going through my 6 statistical checks, I did find that income was a good explanatory variable for vegetation levels. And I did find that, so I didn't have any redundant X variables. I included population as well, because as part of the Becker et al. Study, population is an important variable. But it did say I did find that I was missing some key X variables. So in the future, it'd be important to include other explanatory variables for my dependent variable of vegetation levels. But the big thing with ordinary least squares is that it didn't account for spatial autocorrelation. And I found that there was spatial non-stationarity in my data set, which is typical when you run an analysis of this kind. Basically, what this means is that within the data set, there are clusters, or across the entire state, certain areas have a stronger relationship than others, or certain areas have a specific relationship as compared to others, which then means I needed to run a geographically weighted regression. So ordinary least squares is a global analysis considering the whole state against itself. Geographically weighted regression is a local scale analysis comparing a single county to each of its neighbors or a distance away from it. So for my regression analysis, I just selected the nearest neighbors technique with the Queen's contiguity with a total of 8 neighbors. So for every county, the 8 neighbors directly next to it will be considered as comparison for this statistical significance. And so this gave me my map down here where I found in purple negative correlations between between vegetation and income, meaning that as income went down, then vegetation went down, and a positive correlation where as vegetation increased, so did income. And this was rather unexpected, and it's rather inconsistent. And so I tried this at a few different levels or a few different neighbor relationships. However, it was, it ended up with about this level, right? Or about this same sort of result right here. And so in this western end, we do see this like correlation between increased income and increased vegetation, but areas that we would expect to see a correlation, such as in areas with a lot of major cities or areas in the Mobile, we did not find expected results or hypothesized results. And so what this shows to me is that there does appear to be a pretty inconsistent relationship between vegetation and income across Alabama. And I believe going forward, I need to solve something that was a problem right from the start and was not considered until I had my final result. And that is that the county level is an inappropriate unit of analysis. And so what I believe I ran into here is a issue with the Modifiable Area Unit Problem, or MAUP, MOP. And this is common in geography, where when you run an analysis, you should run it at two different scales. And so in the future, I would like to retest this analysis with a census tract unit to better represent vegetation levels and vegetation distribution across the state to see if there's a stronger correlation, either negative or positive, as it relates to vegetation. Well, that is all I have to share with you guys today. I appreciate any questions, and I thank you all for taking the time to listen to my presentation.